Okay, students, so next is question number 3D. Okay, so what is the function here? Function is fx is equal to modulus of x minus 5. Now all of you know what is this modulus function is, right? Modulus function means whatever inside it will be, whatever value comes out here, negative or positive, output will always be positive. Okay, this modulus function means that one, because this modulus function is actually what? It's a magnitude, right? Magnitude can never be negative. Okay, so how to solve this one? Now the question is what? Question is to check this function is continuous or not. Now did they mention at what point? No. So you have to check at every real numbers. Okay, means x, I have to take all the real number and I have to check at those points whether the function will be continuous. Function continuous means graph will break or not. Okay, and I told you graph will not break if x, for x, every x, if you get y, means what? That point is there. Next point also you take it x. For that, if you have y, means what? Graph is not breaking. Means for every x, if you get y, means graph does not break. Okay. So anyway, how to solve this one now? Now by looking at this equation only, I can easily say that the graph will not break, because see, x, whatever you take it here, negative, positive, whatever real number, defined value will be there, right? Y will be there for sure. Yes or no? So when you draw graph, if you take x, any real number from the graph, here you take any real number from here or here, y value will be there, means that point is there. This point next to this, whatever x you will take, next point also will be there. Next, whatever x is there, take it, y will be there, means what? All the points you will get at every point of x, right? Means if you get all the point here for every value of x, means what? The graph will obviously not break, because you will get all the points here like this. Okay, so just by looking I know that it is continuous, but the problem is I cannot show with graph. I have to show with the help of concept of limit, right? So how I will show you? So limit concept, what it says, limit as your x tends to general point you have to take c, fx is equal to, you have to show fc, it is equal to, right? This was the definition of continuous function, and I have also explained this one. So first you see that explanation properly and understand this meaning, then only you will find it easy. Otherwise, I know most of the student will find this one complicated. The reason is you are not able to understand this one. So you just see those videos where I have explained this one. So first videos are very important there. Okay, so try to take concept on this one, how we got this, then you come here, then you will find it very easy. This one you will understand what I'm going to write now. So first thing, I want to find limit. I already know that this is continuous, right, with the graph. Okay, so I have to show with limit. So see here, this is what function? Modulus function, right? And modulus function we used to split into normal function. So how we will split? First let me split it into normal function. Now see, split means what? What will be the output? What kind of output you will get? You have to write down that one. Okay, now see, in this case, if I take here x5, what you will get? 0 inside, right? Now if you take x5, you will get 0 here, then modulus of 0 will be what? 0 only, means what? Whatever you got inside, same output came out. Okay, means this does not mean here anything, because whatever was the input here, whatever you put it input, after solving, whatever you got inside the modulus, output was also exactly same. So when I take 5, 0, so output also 0. So same thing, x minus 5 only you got output if you take 0 or 5. If you take greater than 5, suppose you take 6, 6 minus 5, how much? 1. So inside modulus you got 1. Now output, what it will be? 1 only, right? Because it's a positive value. So what you got when you put 6 minus 5, it is how much? 1. So whatever was inside, same thing you got, means what? X minus 5 only. When I take 5 or 6, or you take any greater value now, 7, 8, 9, 10, whatever you take, 10, if you take 10 minus 5, it's 5 only, right? Means output will be what? Same, 5 only. Means when you take x, when you take greater than 5 or equal to 5, what is your output? Same thing, whatever is inside, x minus 5. So if I don't put modulus now, problem solved, same thing you will get, right? I have already mentioned x, when you will take greater than equal to 5, then you will get whatever is inside, output also will be same. So this modulus will not mean anything here. Okay, so without putting modulus, see, I have written the function. Now this is only for x greater than equal to 5 I have written. You have to check for everything, right? So less than 5 also what will happen? Now see, if you take less than 5, suppose you take 4, then what you will get? 4 minus 5, how much you will get inside? Minus 1. Now this output, what you will get? 1. Now whatever you are getting inside, you are not getting same thing as output. Now this modulus means what? It will make it positive because of this. So it will make it positive means what? Opposite sign you are getting, right? If it is minus, you are getting here plus. So if I don't want to mention this one, how you will write this one? Can I write like this? Minus 1 is equal to, this is 1, right? This 1, can I write like this? Minus 1. Can I write? Now this minus 1 is what? X minus 5, right? Inner portion, this one. And this minus I have put myself. Okay. Now this way I can define this modulus. See here. Inside modulus, if I put x less than 5. Listen carefully this one. If I take x less than 5, anything you take less than 5, you will always get inside negative value. But your output is other value. That is opposite sign. Positive it will be. So how you can make this one positive? By putting another minus. So inside what you will get? X minus 5, this is your inner portion, right? And this will be negative, but the output, the function must be always positive. So if this whole portion is negative and you want to make it positive, how you make it? Put minus. I hope it's clear. When you take x less than 5, then this portion will be negative. But we know that function fx is modulus function, so it will always, its output, this answer will always be positive here. So this answer must be positive. We know that if I take x less than 5, this will be negative, so this will become negative value, right? But the function must be positive. So if you want to make this positive, what you will do? Put minus, one more minus here. Okay, so I have defined this function in this way. When your x is greater than equal to 5, it will be x minus 5. When your x is less than 5, it will be minus x minus 5. Now it will be easy for us to deal with limit. Okay, so see how I will deal with limit. Now first thing, x tends to what you will take. So our aim is to show for all value of x, limit must exist, right? For all value. It is not for particular value. So I cannot take limit tends to only this particular value. I have to take for all, so I will take in general. So what I will take? Limit tends to C. Now the question is, see carefully. Okay. First I will write down, let C belongs to set of real number. Means C can be anything. Okay, from here. Now see, if you see the function carefully, now see here, if I take x greater than equal to 5, means 5 and greater than equal to 5 if I take, what will be your y value? If I take x5, your y value will be 0. Means here only, this is the point. Next point, just after that, if you take 5.0001, suppose like that you will take, then y you will get what? 0.000.1, something like that you will get. Means the point will be somewhere here. Next point also you got it. Can you see? Just next to it, after that you take x. Again y you will get somewhere here. Defined value only you will get, right? X next value you take. Y you will get somewhere here. X next value. Y you will get here. So if you keep on taking x, all the values, y value you will get. Means what? You will get all these points. Right? Means from the graph function only you need to understand that this x minus 5 will not break when you will take x greater than equal to 5. Right? This y value, this is your y value. This won't break when you take x greater than equal to 5. So how I will write in terms of limit? So I will take something like this. See here, as your x tends to, I will take C, right? Now see what I will take first. C, I will take greater than 5. Means C greater than 5 means I am taking all these values. Okay, now for all this value I will show it is continuous. So limit I will show for this portion x greater than 5, I will show that the graph will not break. Then I will show less than 5 also, graph will not break. Then I will show at here this point also, graph will not break. Okay, I hope you have understood. For all this point I will show the graph does not break. So how I will show that one? Graph does not break, I will show with the help of concept of limit, right? So for c greater than 5, what I will write, limit x tends to c fx. I will show this one equal to something. Okay, then I will find out fc, what it is. If both are equal, then I will say that graph is continuous here. That was the definition, right? Limit x tends to c fx is equal to fc. If you get this, then your graph continuous. So first I am taking c greater than 5, then I will show for this portion the graph does not break. So as your x tends to c greater than 5, right? So fx will be how much? Now do we have to take left hand limit or right hand limit here? See, suppose c is this one. Do we need to take left hand limit and right hand limit here? Do we need to take minus here then plus here? Obviously no. What is your function here? X minus 5. So if you take x minus 5 as your function, then obviously if you put c here directly, it will be defined determinant value, right? So whenever it is determinant value, no need to put minus or no need to find left hand limit and right hand limit. Both will be same if it is determinant value, because in left hand limit and right hand limit, what we used to do, c directly we used to put. If it is indeterminate, then we used to simplify. At that case, it might be different value you get. Okay, so since this is determinant value, simply write down c. No need to find left hand limit and right hand limit separately. Okay, so this will be how much? C minus 5. Okay, so limit fx as your x tends to c, fx will tends to what? C minus 5. It means that, okay, as your x tends to c means what? C, if you take suppose 1, then your fx will tends to, your y will tends to what? Towards from left side as well as right side. As your c suppose 1, then your from left side or right side, as you tends towards 1, your y function also, that is fx also will tends towards something. What is that something? 1 minus 5, that is minus 4. So obviously it will be down here. Okay, minus 4. As your limit tends to, x tends to suppose 2, if you take, see I am taking general, right? That's why I'm showing for all the points. Suppose you take 4. This means what? That's what I'm explaining. As your x tends to 4, suppose c is 4, as your x tends to 4, your fx will tends to what? 4, if you put here minus 1. Minus 1 is suppose this one, your fx will tends to minus 1, like that. Okay, this is what the meaning. In this way you will get point, many point you will get, and this graph will not break. I will show you how. Now next what I will find? fc. fc, what it will be? If I take fc, c I am taking greater than 5, right? So for greater than 5, this is the function x minus 5, that is c minus, in place of x, c minus 5. So fc also I got c minus 5, same. So therefore f is continuous. I can say, right, for c greater than 5, that is x greater than 5, graph does not break. Continuous for c greater than 5. Now we'll show for less than 5. Limit x tends to c for c less than 5. Okay. Oh, and one more thing, I cannot take 1 here, right? I have taken x greater than 5. So if you take 5, then what will be a function? Fx will be always up here. Okay, function value 5 if you take, means x come closer to 5 from left as well as right. What will be a y value? Y will tends towards 5. If I take 0, means here your function will tends here. If you take suppose 6, as your x tends to 6, your fx will tends to what? What does it mean? 6 minus 5, 1. So 1 will be here, right? 6, 1. So your fx will tends to towards this side. Okay, as you take 7, then you will get this point, your fx will tends. In this way, if you take all the points here x like that, y you will get this one. Okay, this is what the meaning here. Next, for c less than 5 we will show. C less than 5 we will show that here also graph does not break. Okay, then we will show at this point also graph does not break, means this point also is there. So this line is there, I will show this line also will be there, and this also will be there. Then what will happen? This graph will not break. Okay, so for less than 5, x less than 5, what graph you will get? So x less than 5. So as your x tends to c, what your fx will tends to. So xc this time is less than 5, means this can be 4, 3, 2, 1 minus like that. So if you take less than 5, this one, what function you will use? Fx will be this one now. So I will take limit x minus 5, which you will get x tends to c. So I can directly put c here. Here also I'm not taking left hand limit or right hand limit. Why? Because this is determinant value again. C minus c minus 5. What you will get? 5 minus c. Now you might be thinking that this and this not same. This and this are same. Now let me find out fc also. See, limit x tends to c, fx, I got this one right. If I get fc also this one, then I can say that left side also it does not break. Well, that's what the meaning, right? This is equal to fc, if I can show, means this portion is equal to fc. So fc, c is what? Less than 5. So function will be which one? This one. So in place of x, put c. So what you will get? 5 minus c only. So you can see limit x fx as your x tends to c, fx tends to 5 minus c, and at c also fx fc you got 5 minus c only, this only. So means what? You can see fc also I find out, means see here c greater than 5 for this portion. I got graph, this is equal to this one I got, means I got graph does not break here. For c less than 5 also I have got the graph does not break. How I knew that? Limit fx is equal to fc. This was the definition of continuous function. Remember that. So better I will write down here. Therefore, limit x tends to c fx, what you got? Fc. So therefore f is continuous for c less than, or you can write for all real number greater than 5. For all real number greater than 5. What does this mean? F is continuous for all real number greater than 5 means for all greater than 5 your fx is continuous, means graph does not break. Okay, greater than 5. At 5 I didn't check till now. Okay, so if I draw the graph properly it will be like this. With this information what I have understood, at 5 I didn't find out whether the graph will break or not. Where I find out? Greater than 5. Greater than 5, when you will take y will be start from here only, right? So I have checked that this does not break, this portion. And when I take x less than 5 I taken, c equal to 5 I didn't took. For less than 5 graph does not break, that also I have seen. See here, what is this? From this x tends to c, fx we got fc here also when your c is less than 5. So here also graph does not break, right? Now this whole thing will not break if this point is also there. If this point is also there, means what? Here also limit, that limit condition must satisfy. So means what I will take? When your c is equal to 0, then I have to show that fc is equal to limit x tends to c fx. This also I have to show when your c is equal to 0. Okay, so after this step I will write down for c equal to 0, what will be your limit? Limit x tends to c, means x tends to 0. Okay, fx. So when your c is equal to 0, which function you will take? Not 0, sorry, at 5 I have to check, right? 5. 0 I have already checked, less than 5 we have already checked. 5, okay, don't get confused. C equal to 5. So c when it is equal to 5, which function you will take? You can see when your x is equal to 5, your function will be this one, right? So fx, what I will take? C is what? 5, right? X tends to 5, then fx function will be x minus 5 only, which is equal to, can I put directly c here? Yes, c minus 5. So I got c minus 5. Okay, what you will get? Fc. Now c is what? Equal to 5, right? So when it is equal to 5, fx, fc, c is equal to 5, means x equal to 5, right? When your x is equal to 5, what is your function? fx will be x minus 5. So x minus 5 means in place of x, c is 5. If you have any confusion in this question, ask me, okay student. fc. I know this is little complicated for you because limit concept is little deep. Okay, so first you need to understand limit very carefully and then you will understand all this question. Okay, basically whatever I'm doing here, I'm just checking whether the graph will break or not. So I have checked it separately. Why? Because modulus function you always have to split like this. For greater than equal to 5, I know. For greater than 5, I know that this function will not break, because greater than 5 if you'll take, always y value will get. Now the chances of breaking is only at 5. That's why we have to check only at 5 whether the function is continuous or not. Anyway, if you have not understood that portion, just listen whatever I have said here. Okay, this portion and this portion. So here also I have shown that limit x tends to c, fx equal to fc. So you can see I had to check what? First thing, I have to check function is continuous at every real number or not. Means x, if you take all the real number, function will be continuous or not. Function continuous means graph will break or not. So I have taken for all x, I have shown that graph does not break. How I have taken x? I have taken first greater than 5. I have shown that graph does not break. Then less than 5, graph does not break. And at 5 also I have shown that the graph does not break. Does not break means what? Greater than 5 when you will take, there will be a gap. It will not touch exactly 5. Greater than 5 when you will take c. Means x, if you take greater than 5 means what? 5.01, like that you will take, right? So y also you will get above that only. So 5 it will not touch at this point. Okay. Now next, less than 5 also when you will take, it will not touch 5. Now if you want to show the graph is continuous or not at every real number, means this also does not break. If it break here, then I will say the function is not continuous. So that's why I was checking that this point also is there or not in the function, in the graph or not. So in the graph it is there or not means what? This point is there, is means what? X and y value is there or not, you have to find out. Means x when you take 5, y value must be this one. Okay, so when you will take x5, you will get 0 or not, so point will be there, so it will touch this point also and it will become continuous. This is what the meaning. I have written in general form this one. Okay, so try to analyze this one, whatever I have explained yourself, and then see if you understood or not. If not, then tell me. I will try this one again in different method. Okay, and I will show you the graph also, you can see now. Here you can see the function I have already typed, fx equal to modulus of x minus 5. So when I draw the graph of this one, you will see that graph will not break at any point. Can you see this graph? See this. The graph is not breaking at any point. So therefore it is continuous. So to graph, it's very easy to find out, right, whether it is continuous or not. But we are studying how to solve that one with the help of limit, because this concept will help you in higher classes to solve many difficult problems. Okay, so limit is very important part of your life. Okay, so try to understand that one carefully. So if you have any doubt, you can ask.